Greetings to KMI Community Connect viewers. We are at part 10 of Metabolism Made Easy. I want to just quickly give a quick summary of what we have talked, because I was telling in the beginning when I was doing pillars of metabolic health that we are going to connect and recap and tie all loose ends. So I have mentioned quite a bit of information between then and now. And so I'm going to bring back everything that we discussed and try to summarize, and I'll be doing these recaps also in the future. So in the last Metabolism Made Easy interlude for part 10, I said that a calorie is not a calorie. That means a glucose and fructose, they both give 4 kilocalories of energy for 1 gram when you burn. But in case of glucose, the difference is, that's why I said a calorie is not a calorie, because in case of glucose, I'll put this in a different color here. Glucose molecule, like I mentioned before, is everything goes into the mitochondria. I'm going to line this in the cell like this as a mitochondria, and I'll just write mitochondria instead of putting a picture. That way it becomes easy. Mitochondria, and then only 20% becomes, I'll put a different marker here, 20% becomes fat and 80% becomes energy. That means it's useful for us to carry on our functions. That means glucose is very vital for carrying on our daily activities, because body makes glucose, and also when you eat glucose, which is not fructose, I'm going to mention that everything goes to making energy 80%, and only 20% becomes fat, which is excess or under various conditions. And where this happens and all, we're going to talk. Now coming to fructose, because a calorie is not a calorie, because 1 gram of glucose gives 4 kilocalories and 1 gram of fructose, I'll write glucose here, also gives 4 kilocalories. But these 4 kilocalories, if you say it, because it's carbohydrate, it's a carbohydrate, 1 gram of carbohydrate, they say. That's when I'm making this into separate glucose and fructose. 1 gram of carbohydrate, they say, give 4 kilocalories, but this doesn't, 4 kilocalories does not happen. That's why I said a calorie is not equal to a calorie. Is not equal to a calorie, because what happens to that fructose now, this is a recap so that you understand and how this pathway works. Fructose, when it goes into the mitochondria, this way or this way, 100% becomes fat. 100% fat. So I will recall what we talked about in the 2 different enzyme pathways. One is AMP kinase and AMP deaminase. Now AMP kinase is what glucose takes, and then what it does is it makes everything into energy. So you are fine, hunting is good, you are in good shape, you don't need to pack away fat, you don't need to make glucose, you can burn fat, you have enough energy, things are good. Whereas fructose activates the other pathway, the 4th that I told you. One is AMP kinase, which is what we want to make energy and everything going this pathway. The other pathway is the AMP deaminase, which makes uric acid from fructose, right? You remember, I will put that here again. So the fructose does all this fat production by making uric acid in the pathway of AMP deaminase that I talked, and that in the mitochondria is a toxin to the mitochondria, and everything becomes 100% fat. So instead of 20% fat, 100% fat. So same 1 gram of glucose and fructose completely behave differently. So you cannot go by the calorie equal to calorie, because everything from fructose becomes, through uric acid, becomes 100% fat, whereas from glucose it's only 20% fat. So this is why I mentioned this. Now the AMP deaminase does exactly the opposite, which is the evil twin, which makes you have to make fat because winter is coming, survival mechanism, we have to store energy, we have to make more glucose, we have to increase the blood pressure, we have to make fat and store it, otherwise we are going to die. That is the signal that is put in by uric acid pathway. So now let's go back, and when I say you have to make more sugar, more blood pressure, more fat making and all, I'll put it in different colors. So this pathway, actually what we are talking about is high glucose we are talking about, and then if it goes wrong we are calling it as diabetes. And then the same pathway that is activating from uric acid, if you are saying increase the blood pressure, which is the AMP deaminase pathway, make more glucose, increase the blood pressure, like I told you, that is high blood pressure, which I put it as hypertension, HTN. Then we make more fat, store more fat, we are calling it as weight gain or obesity. So all these are symptoms, we are calling it as obesity, and they are all coming from one mechanism, which is uric acid pathway, but they also come from glucose with this 20% fat, which I will try to connect it. So all these things, so let's put all those pictures of what happens where when you say high glucose, this is the liver is the most important organ for this, because the liver makes more glucose all the time. So we have to mark liver here, because that's where it makes, and that is again in turn controlled by an organ which makes insulin here, that's called pancreas. It's a leaf like organ, so I'll put that, and that makes insulin, and that will act on the liver and other tissues. We are also going to put that other tissues which are very important, which is fat cells, and that's fat. And then I am also going to put the other tissue which is also very important, which is muscle, and that's muscle. And then the rest of the organs, which is the brain, heart, and all the tissues that utilize it, kidney here, I am going to put that they use glucose, and all the other organs, we'll list it as we go by when we talk. So this is where these things get connected. Let's connect it. High glucose because it's action on the liver, and then high blood pressure means it acts on the heart, it acts on the kidney because the mechanism drives through kidney, and the effect is on the heart, and then it also has its effect on the brain. So high blood pressure, its effect on the brain, heart and kidney, and also a little bit, next thing is the fat. The fat making obesity, now that has its effect on the liver, it has its effect on the heart here, and it has its effect on the muscle because it breaks the muscle and you make more glucose. So what I will do on my next talk is connect and give you more details about how things happen and what are the foods. We talked a little bit about eating fructose, various sources that come from outside. So it's not just eating fructose. Your body, when it goes through certain conditions like stress on the body, like not eating which is a stress, and it goes into uric acid pathway, which is starvation, not drinking water, which is dehydration, not getting enough oxygen, which is hypoxia, it's called low oxygen states. Any kind of stress will start converting the pathways from even glucose to fructose and the pathways. That's why when I talk to some of my patients, they say they stopped eating sugars, they stopped eating fruit juices and sweets and drinking sodas, but still they're making fat and they're not able to lose weight. And there are some of the other non-caloric things that we are going to talk, like salt, which has no calories. That's why I mentioned a calorie is not a calorie. Salt, which has no calorie, has the potential to make a lot of fat in the body. So dehydration is a signal, eating salt is a signal. I will explain that mechanism. That is again connected to kidney and the heart and the brain, and how insulin plays a role in that, and how fat plays a role in that, why you make more fat. All those mechanisms I am going to be talking in my part 11 of Metabolism Made Easy. For now, I just wanted to connect everything, recap everything, and then put these arrow marks so that you understand that they are all connecting together, and they are all different symptoms. Having high fat, high blood pressure, high glucose is all the same pathways. Even excess glucose, which converts to excess fat, can trigger these mechanisms. So it's the same pathways that are happening, and I just wanted you to appreciate the underlying pathways, because in Metabolism Made Easy, this is what you'll try to appreciate, so that you will then know what we need to do for driving those exact physical signals that we need to give, like I mentioned about dehydration, starvation, salt intake, and not taking ourselves into a false pathway of a survival mode, which is not the case, and why those pathways are there to really help us during survival or dehydration when it is a life-saving situation, and how we can give those signals. I will be coming back and talking to you more in detail about all those foods and how the body converts into fructose even if you don't give fructose. Thank you very much. I'll talk to you very soon.